That's what we learned last class period, is how do I prove those triangles congruent, right? After you've proved them congruent today, it's really just one extra step. Now that I know they're congruent, all of their corresponding parts are going to be congruent. So when you'll use this is if, let's say, for example, you have these two triangles and you have proven they're congruent. Which shortcut did I just draw? SAS. So you went through your proof, you proved they were congruent by side angle side, and now it may say prove, instead of saying that the two triangles need to be proven congruent, it may say prove AC is congruent to DF, which is a part of the two triangles. And so we don't have a theorem or a way to get that those two sides are congruent, but if we can prove the two triangles are congruent, then we can go one step further to say, now all of their corresponding parts are congruent by CPCTC. So that means that these two sides would have to be congruent. Does that make sense? So it's really just one extra step. Sometimes it's two extra steps depending on what they're asking you to prove. But the big idea is you're just going one more step after what you've already learned how to do. So not super hard today. Okay, I already said all that. So they're not all going to be proofs on your homework. They are going to be some where you're just solving but using the idea of CPCTC. So they want you here to find the distance from A to B. And so you look at the picture, you're trying to find this distance right here, AB. First thing you would need to know is, are these two triangles congruent? And if they're congruent, what is AB going to have to equal? Okay, so if you look at the two triangles, if they're congruent, which side would AB match up with? 18 miles, right? Is everybody with me that they look like that's how they would match up and land? Okay, but we have to know they're congruent first, or we can't say that AB is 18. So it's easy on the measurement, but we have to be able to prove it. So what do I have here that would help me prove the two triangles are congruent? Okay, I heard vertical angles. Does everybody agree that these angles have to be congruent by vertical angle theorem? Okay, so vertical angle theorem. What else does the picture tell us? Okay, so there's some congruent sides. So this one's 15 and this one's 15. So these sides have to be congruent. And this one's 10 and this one's 10. So those two sides are congruent. So if we mark what they told us and we use vertical angle theorem, are these two triangles congruent? And why? Very good. So then we could say the triangles are congruent by SAS, which means AB has to equal 18 miles. And what's the reason today that we can say AB is 18? By CPCTC. Because if the two triangles are congruent, now all their corresponding parts are congruent. That making sense? Questions? All right. So then we jump in and we have some proofs, right? And do I just have all proofs left in the examples? I can't remember. Can I scan? Is it on the back too? Yes, so we just have a bunch of proofs, right? So we're going to do several of them today. And it's going to help us with the last lesson because we're going to have to prove them congruent again. So if you were struggling with 4-5 or 4-6, this will just help reinforce that. And then we'll go our steps further. All right, so, and this shouldn't take the whole time, and then I'll give you your assignment and you'll have time to work today, okay? It's going to be a short lesson. So statements and reasons. Number one, what do we always start with? The given. And do we write all the given at once? I wouldn't. It's not wrong, but I wouldn't. I would start with the first thing you know. YW bisects XZ. Number one, given. Then we're going to go to our picture and we're going to ask ourselves, if YW is bisecting XZ, what do we now know we can mark congruent? Naya? Careful, correct, but be careful how you name it. X is going to land on what point? Z. So when you say XW, you need to say, there you go, XW and ZW. We want to keep matching up our points at all the time. So you are correct. We can say XW is congruent to ZW and Y. What's our reason? Okay. Always look for the word that they gave you. If they gave you a word and that's what you use, that's going to be your definition. So definition of, and this time it's a segment, so definition of segment bisector. If it's an angle, it'll be angle bisector. Okay, so we have one side marked congruent. Go back to your given. The given tells you now that XY is congruent to, and that's typo again. What should that say? ZY. So let's fix that. So XY is congruent to ZY, keeping our coordinates and everything matched up. So XY and ZY. And that is given. Mark your picture. So now we have two sides congruent. Do you see a third thing we can do? Very good. YW is congruent to YW, and it would be reflexive property. Great job. So number 4, YW is congruent to YW. Anytime something's congruent to itself, that's reflexive property of congruence. So now what do we know about the two triangles? They're congruent. And why are they congruent? Side, side, side. So now we can state that our two triangles are congruent. You have to state that they're congruent. So I'm going to say triangle. How do you want to name the first one? Okay, I heard YXW is congruent to triangle. Now you're going to have to be careful today because now you're coming up with the congruent statement. So YXW is congruent to what? Good, triangle YZW. So make sure you are matching your parts up correctly. And you said that was side, side, side. And then here's our extra step. Now that they're congruent, we can say, and notice what they told us to prove, an angle is congruent. Be careful you don't see that as a triangle symbol. Sometimes it's easy to get confused. Are they saying angle or triangle? Because they're close, but it's angles. So we go a step further to say angle XYW is congruent to angle ZYW. And XYW and ZYW are just those corresponding angles. And what's our reason? Okay, CPCTC, every other letter is a C. P comes before T in the alphabet. Corresponding parts of congruent triangles have to be congruent. Yes, sir. No, the old way, the only reason I taught it to you, definition of congruent polygons, where you have to get all 6 parts, is so that if you had to prove shapes other than triangles congruent, you could do that. But on the test, we're going to focus on just triangles. And so for focusing on just triangles, then you can just use your shortcuts. Okay? Mm-hmm. No, and that's why it's a T. Corresponding parts of congruent triangles only are congruent. Okay? Other questions? All right. I'm going to look at the proofs and see which ones I think we need, if we need to do all of them or if there's some we could skip. I might need to do that one. Yeah, we probably won't do all of them. Let's see, though. I think we do need to do, we'll see. Let's at least set this up and see if we can figure out what we would mark, and then maybe we won't fill out the whole proof just to save time, because this one's a pretty easy one. If it says PR bisects angle QPS, I want to make sure you understand what you can mark congruent from that part of the given. What can we mark congruent? Okay, say again what you said there, Naya. Careful, PSR would be this angle. There you go. Okay. So we could mark those two angles congruent because this angle right here is being bisected. QPS. Is everybody understanding that? QPR, SPR. Okay. And then if it says that PR bisects angle QRS, what could we say is congruent? Okay, so name it. Weston? Careful. There you go. So if you started at Q, QRS, Q is going to land on top of S when we match them up. So it's SRP. Is everybody clear there that we could say those are now congruent? Okay. And then what would be the missing thing that we would need to mark congruent? PR. And why would PR be congruent to itself? Reflexive property. And then why are these two triangles congruent? Okay. ASA, right? Angle, side, angle. And if the two triangles are congruent, then why is PQ congruent to PS? CPCTC. Is everybody with me there? Okay, I'm not going to write that one all the way out. Feel free if you want to. It'll be in the filled in notes. If you want it filled in, you can look at that when I send that out today. But that's the big idea, going a little faster on that one since it was easier. Questions? Okay, let's do the next one and we'll write it all in. So, helpful hint here up on the board. I don't think I put this in your notes, but if you look up here, sometimes when your proofs say something different than what you're used to, because the next one's going to ask us to prove lines parallel, I believe. Is that the next one or the one after? Okay, the one after, the next two, right? The next two say prove lines parallel. Okay, so we're coming up with some that we're going to try to prove parallel. If you don't know what you should do to answer the question, sometimes it's good to work backwards and start saying, okay, if this is what I want to prove, what theorem would let me prove that? And then what would I need to know to be able to use that theorem? And then work backwards to try to come up with a plan. So that may be what we have to use when we start working through some of these where we're trying to prove lines parallel. So let's go back in our minds. Chapter 3, we proved lines parallel. How many different ways did we learn to prove lines parallel? It's actually 6. There were 5 that started with what 2 words? Converse of. So we had the converse of same side interior angles, converse of same side exterior angles, converse of the corresponding angles postulate, converse of alternate interior or alternate exterior angles. What was the 6th way? Didn't have a name. We talked about if 2 lines Okay, that would prove perpendicular. What's the one that proved them parallel? Should be in that same section there.
Oh, I got it. If 2 coplanar lines are perpendicular to the same line, then these lines are parallel.
Exactly. Is it not back there, Ivan? Then it may just be in the actual section. Nope. Nope. Oh, right here. Nope. That's the same one you read. I don't know. It's in the section. Then it's not back there. That's not good. So it is missing one in the very back. But you are correct, Weston. If 2 lines are perpendicular to the same line, then those 2 lines are parallel. So we've got 6 ways we can prove lines parallel. That's going to be our goal here, is to prove MN, this line right here, parallel to OP. Okay, so the first thing you may want to ask yourself is, what am I going to need to prove those 2 lines parallel? In the picture, do we see one of those 5 converses, or do we see that we might have 2 lines perpendicular to the same line? Okay, so probably one of the 5 converses, because it doesn't look like the lines are perpendicular, and I don't see any information up here that might get me that they're perpendicular. Good, Weston. Do you guys see that this is a transversal? And then if we could maybe get this angle congruent to this angle, then we would have the converse of the alternate interior angles theorem. Okay, so what I have in green is what our goal is. We've got to get there, but we don't know that information yet, right? That's our goal. So what we learned last class and what we're learning today is if we could prove these two triangles were congruent, then their corresponding parts would have to be congruent, right? And if we could get these corresponding parts congruent, then the lines would be parallel. Does that make sense? All right, let's see if we can do it. So I'm going to erase this because we don't know this in green, but that's what our goal is. And let's start with what we do know and see how far we can get. So statements and reasons. Did I give you a chart this time? Okay. I don't know why I didn't on the other one. Sorry about that. So number one, we have NO is parallel to MP, given. Mark your picture. NO is parallel to MP. Okay, so just based off of that, what could we mark congruent in our picture? And why are those angles congruent? Okay, so do you see that we do have one pair of lines parallel, which results in a different pair of alternate interior angles being congruent, but these two angles are not the ones we want, right? We eventually want the other two alternate interior angles so that we can say those lines are parallel. But we can start with the ones that we know are going to be congruent. So number two, and Anna did a great job naming those, NOM is congruent to angle PMO. And what's the reason? Careful, are you proving lines parallel? There you go, not converse unless your statement is about lines being parallel. Our statement is about angles being congruent. So it's alternate, interior, angles, theorem. Okay, so we have one angle marked congruent. If we want to prove the triangle's congruent, we've got to get three parts. The next thing they tell us is that angle N is congruent to angle P. And that's given. Angle N is congruent to angle P, given. Now at this point, I'm going to see what you can come up with. We could go the long route and prove the two triangles congruent and then use our corresponding parts, CP/CTC, to get those other alternate interior angles congruent. Or there's a shortcut we could do here that would not require us to prove the two triangles congruent. Does anybody see a way we could get the other angles that we're looking for congruent?
Use your third angles theorem. That would get, the two triangles. And then you could say that all the lines are congruent.
We don't need to say the lines are congruent, but you are right. We can use what theorem again? Third angles theorem. Is everybody with Weston that if these two are congruent to these two, that means the third angles have to be congruent? Okay, and angle doesn't prove triangles congruent, so this is not trying to prove the triangles congruent here. This is trying to get those alternate interior angles that we wanted congruent. Does that make sense? And that'll make this a shorter proof if we recognize that. If you didn't recognize that, you would have to prove the two triangles congruent, then use CP/CTC. How would I have proved the triangles congruent if I didn't do this shortcut with third angles theorem? What would have been the third thing I could have marked in the picture? Okay, I could have done MO is congruent to, and be careful, it would be OM, because now these angles are the ones that match up. And that would have been by what property? Reflexive property. And that would have given me angle, side, right? And then we could have used CP/CTC. That makes it take a lot longer. So I like the idea that Weston had there. Let's use third angles theorem. Now let's name those angles correctly. How would we name them? Angle NMO is congruent to angle, say it again, POM. And that was third Angles theorem. And what we started off this proof with was if we could get those angles congruent, then the lines would be what? Not congruent, parallel. We're trying to get them to be parallel, not congruent, not equal, parallel.
I was thinking of all the lines, and then you could go back to say
Okay, CPCTC proves parts of triangles congruent after you've proven two triangles congruent by side, 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 angle, side. We aren't using those 5 shortcuts. We're just trying to get these angles congruent because now our new goal is not to prove parts congruent. Our new goal right here is to prove lines parallel. So this is taking what you learned in chapter 3 and what you learned in this chapter and putting them together. Okay? And we could use CPCTC to make this longer, or we could use the shortcut that you said, which was third angles theorem. If we can get the third angles congruent, then now we have the alternate interior angles we needed to say these lines must be parallel. Are you with me, Weston?
So how did you get from third angles to those lines parallel?
Okay, that's where we're headed right now. So number 5, MN is parallel to OP. And what is the reason that they're parallel now? Okay, these are alternate interior angles, and if they're congruent, then the lines that make them are parallel. So that's the converse of the alternate interior angles theorem. But again, you could have used reflexive property instead and then said the two triangles were congruent. And if the two triangles are congruent, then you could have done CPCTC to get these angles right here congruent. And if those angles are congruent, then the lines are parallel. Are we understanding, everybody? Don't sit quietly confused. Let me know. Okay, let's try another one. How many are left in our notes? 3? Okay. I don't know if we'll do all 3. Let's look and see if we need to do all 3. Let's just talk about this one and see if we can do it without writing it all out, and we'll get to the other ones on the back that are a little harder. So J is the midpoint of KM. If I take this part, what could I mark in my picture? Okay, KJ and what? MJ. Okay, so we can mark those congruent. First of all, let's look at what we're trying to prove. I should have started with that. What is our goal here? Okay, we want to get this top line parallel to this bottom line. So once again, we're looking for one of those 6 ways. Either we're going to get some angles marked congruent and we can use the converses, or we're going to try to get some perpendicular lines so that we can prove they're parallel. Okay? So I've got one piece marked congruent here. Then I go back to my given. It also said J is the midpoint of NL. So what's congruent based off that? NJ and LJ. Is everybody okay with that? Okay, which 2 triangles do we need to be focused on here? And why? Anna, why do we need to focus on the top and the bottom ones? Okay, but there's also other alternate interior angles in these 2 triangles. So why do I need these 2? Okay, because we want to prove these 2 lines parallel, and those are in the top and bottom triangles, right? So we need to focus on the ones that contain the lines we're looking at. Okay, so we've got 2 sides in the top and bottom triangles. What's something else, because we're out of given, that we could mark? The vertical angles. So we could mark these vertical angles congruent by our vertical angle theorem. And now, do we have enough to say the triangles are congruent? And why? Side, angle, side. Good. S, A, S. So we have side, angle, side. And if the 2 triangles are congruent, which parts do we need to be congruent that would prove the red lines are parallel? Okay, so M, N, L, and angle K, L, Actually, sorry, it should be angle MNJ, is congruent to angle KLJ. Why do we want those angles congruent? So just like the last one, those two angles would be congruent. Why though? Why would these be congruent? Okay, so I want to make sure we're all together here. This angle was congruent because of vertical angle theorem, since I'm not writing this all out in a proof. This was congruent by vertical angle theorem. The two triangles were congruent by side angle side. So why are these two angles congruent? CPCTC. And now if those two triangles are congruent, why are these lines going to be parallel? Okay, without writing it all out to make it a little faster, is everybody following me there? And again, if you need it all written out when I send the link out today, fill your notes in tonight with the filled in proof that you'll have. Because it'll be listed just like this, and you can write it all down. Okay? Is everybody okay that we didn't fill that all the way in? Okay, because I want to make sure we had time to do the two on the back. They're a little bit harder. So let's focus on these. Okay, this one to me is a little more complicated for lots of reasons. But first, there's a lot of triangles in the picture. And it doesn't ask us to prove triangles congruent. It asks us to prove two sides congruent. So that means the first thing we're going to have to try to figure out is if we are looking at CPCTC, which two triangles do we even need to focus on? Okay, so first I would figure out where are the two sides we're trying to prove congruent. So AR and BQ. So we're going to try to get those two line segments congruent. There's a couple different triangles that are made by those two lines. So then I would probably go up to my given and see what are they giving me information about that I could mark. So they're telling me that triangle PQR is isosceles. What is that going to tell me? Okay, so there's at least two congruent sides, so we know for sure we're going to have two that are congruent. And what do you think them telling me that base QR is important? Okay, so they're telling you the two that are congruent are not going to be QR. QR is the other side of the triangle. So if QR is not the two congruent sides, which are the two congruent sides? Okay, so PQ and PR. So we're going to know those two sides are congruent. Kind of hard to mark when they're overlapping like they are right now. But keep in mind, those are going to be congruent. And then what else do they give us? Okay, so this distance PA is going to be congruent to this distance PB, right? So now you need to take all of that information and look at that picture and see if you can see which two triangles do we need to pull out of that picture and relabel and look at. You're saying PR, BR, this little piece? Okay, that's not going to contain the red line or the blue line. We're trying to get this whole red piece congruent to this whole blue piece, and this little triangle right here would not contain that whole piece. Oops. Oh, I went too far. There we go. So what two triangles would contain the two lines that we're trying to prove? Sorry, I'll come back to you, Cooper. Bree? Okay, maybe BRQ does contain this blue line, but BRQ doesn't have any of the other things that we've marked congruent in it, right? It doesn't have this PB in it, and it doesn't have the PR in it. So that may not help us if we focus in on that one. Cooper? Okay, PBQ, so I'm going to trace the one you're talking about. PBQ would be this triangle. That does have this PB marked. It does have the QB marked. And it does have the PQ mark. Do you guys see that? And then you said which other one? PAR. So I'm going to trace that one. That one has this marking. It's got the one we're trying to prove congruent, and it's got this other marking here. Do you guys see how those two contain everything that we can figure out? That's the hard part of this one. You've got to really look at the picture and try to figure out what do you even need to focus on. And then my advice is to redraw them and separate them from your picture. So I'm going to redraw them and remark them. So I've got this P, B, Q, and we had PB with 1 mark, and we had PQ with 2 marks. And our goal is to get this BQ side congruent to the AR side. Don't let me go too fast. Is this making sense so far? Okay, and then I'm going to come over here and I'm going to draw this red triangle. So the red one was PAR. So PAR, and we have the PA is marked congruent to the PB. And we have the PR was going to be congruent to the PQ. Now we haven't written all that down yet, and we're going to in our proof, but I want to make sure that we at least have the 2 triangles figured out and marked. Everybody good? Okay, so let's start listing what we've marked actually in our proof. So I'll try to cram this in small here. So I've got statements and reasons. So number 1, we're going to start with our first given, which was that we have isosceles triangle PQR with base QR. And technically that QR should have a line segment above it for good notation there. So isosceles triangle PQR with base QR, and that was given to us. So back in your mind and think, what did we say from that given about triangle PQR since it was isosceles? What did we say? What did we mark from that given? Okay, and which 2 congruent sides? Okay, PQ and PR, right? Those were the 2 sides, and we knew it was those 2 sides because they called the base QR. So it had to be the other 2 are the legs of the isosceles triangle. So number 2, PQ is congruent to PR. And those are marked in our picture already. How did we know that? Where did that come from? Okay, the definition of isosceles triangle, that it has at least 2 congruent sides. So definition of isosceles triangle. Okay, and then after we wrote that down, we went back to our given and we wrote down that PA was congruent to PB, and that was given. All right, and again, our goal is to get the third sides in the picture congruent, and there is no such thing as a third sides theorem. So we're going to have to figure out a way to prove those 2 triangles congruent so we can use our CP/CTC. Does anybody see what is the third thing we could mark in the picture and why? Cooper? Which angle? So you're saying this angle here would be congruent to? PAR. What tells us those 2 angles are congruent? It's a good idea, but I don't think we have a theorem to back it up to say that those are congruent. So we have to have a theorem, a postulate, or a property, and I don't think we have one that would say those are congruent. Okay, so you're saying RPA, this angle, is congruent to QPB, which is the same angle. Do you guys see how it's the same angle in both triangles? And when 2 triangles overlap or are side by side and they share a common piece, why is that piece congruent to itself? Reflexive property. We've used that a lot for sides. We haven't used it a lot for angles. But if you see that they share the exact same angle, and that happens often when they're overlapping, then it's still reflexive property. Annie, you did a great job naming those, so I'm going to go back up here. Number 4, I think you said QPB, is that correct? Angle QPB was congruent to angle RPA. And that was the reflexive property of congruence. And again, if you ask me, Miss Lashley, I don't know which reason it is, the first thing I'm going to ask you is, did you draw your picture? Did you separate your triangles? And did you mark your picture? Because now that we've separated them and marked them, it's very obvious why the two triangles are congruent. Which of our 5 shortcuts do we have? Side, angle, side, right? So now number 5, let's make sure we can name them correctly. Triangle what? Okay, triangle PAR is congruent to triangle PBQ. Good. So just make sure you're matching the parts up correctly. And the reason will be side, angle, side. And now the new thing today, if they're congruent, why are those third sides congruent? CPCTC. Again, there's no such thing as third sides theorem. There is a third angles theorem. So use it when you can to help save time. But in this case, we had to prove the triangles congruent first, and then now their corresponding parts are congruent. So CPCTC. Every other letter is a C. P comes before T. Questions? Okay, I'm going to give you about 5 minutes, and I want you to see what you and your partner can do on the last one, and then we'll check it out. So let's check and see how much you were able to figure out on your own. So, statements and reasons. Number 1, you should have started with X is the midpoint of AC, given. Okay, guys, if X is the midpoint of AC, what did that tell us? AX is congruent to CX. Questions on how Anna got that? Okay, so number 2, AX is congruent to CX. What's the reason? Definition of midpoint. The word they gave you was midpoint, and you knew that meant to split a segment into 2 congruent parts. It's the point that does that. So definition of midpoint. All right, so then we have that marked. We go back up to the given, and we have that angle 1 is congruent to angle 2. Mark that in your picture. Angle 1 is congruent to angle 2. And that was given. Okay, and then that's all they tell us. So let's see what our whole goal is here. We're trying to prove what? Okay, we're trying to prove X is the midpoint of BD. So if X is the midpoint of BD, what do we want to get there? Or what should be true in order to say it's the midpoint? Okay, so if X is the midpoint of BD, if this is true, then what we need is that DX is congruent to BX. Agreed? Definitions are biconditional. They go both directions. So if these pieces are congruent, then it is the midpoint. And when it's the midpoint, then the pieces are congruent. Okay, so it goes both directions. So we need these 2 things to be congruent. So which 2 triangles do we need to focus on in this picture? Exactly, the left and the right. We need to focus on this triangle and this triangle because those are the triangles that have the markings in them that we have congruent. This side and this angle are in this triangle. This side and this angle are in this triangle. And they're the ones that contain the 2 pieces that we need congruent. Does everybody see that? Okay, so right now we have 1 angle and 1 side. What is the third thing that you can mark congruent in the left and right triangles? Go ahead, Ivan. Vertical angles theorem. Can you name the angles that are in that picture that we can mark congruent? Okay, DXA, so that's this angle, and BXC, good. Making sure you're matching those parts up correctly. We started at D and went to the 1 mark here. Actually, I need to use 2 marks. So we went from D to X, and that's the longer piece here, so we're going to go from B to X. So BXC. And Ivan said that's the vertical angle theorem. Okay, and so now if we mark those 2 angles, what is the way that we now have the left triangle congruent to the right triangle? Okay, so we have angle, and then a side, and then an angle, right? So angle, side, angle. So number 5, we would have triangle. Name them correctly. How would we name them? Okay, I heard DAX is going to be congruent to triangle. Match your angles up. So D is the one that doesn't have a mark, so that means we're going to start with the triangle angle over here that does not have a mark. B. A had the 1 mark. C has the 1 mark, so B, C, X, right? And again, that is angle, number 5, angle, side, angle. And if the 2 triangles are congruent, so now what parts did we need to be congruent to prove that X is the midpoint of BD? DX and BX. So then you're going to write DX is congruent to BX. And how did we know that? Okay, that's the new things today. C, P, C, T, C, because now that the triangles are congruent, their corresponding parts are congruent. So now we have these 2 pieces congruent, and if those 2 pieces are congruent, X must be the midpoint. So 7 would be X is the midpoint of BD. And how did we know that? Definition of midpoint, it's going backwards. So definition, I'm going to abbreviate there, don't abbreviate on your homework. Definition of midpoint. Yeah. Questions?
We used 2 different triangles.
Okay, which 2 triangles did you try to use? Okay, and so I'm with you that you would have had this side marked congruent, but that's not congruent. Yeah, this side would have been congruent to this side, but that didn't contain your red angle, so how did you get 3 parts congruent?
Vertical angles theorem and altered interior.
Okay, the problem with that is you do not have parallel lines. Chapter 3, the entire premise is if 2 lines are parallel. So great idea, but there were no lines given to be parallel. Does that make sense, guys? If those lines had been parallel, you totally could have used the top and bottom triangles. You could have done exactly what you did and it would have worked perfectly. Okay, so be real careful. All right, any other questions on today's lesson? All right, this assignment is not super long. Get as much done as you can so you can go home with less work this weekend. You've got a good 20, 25 minutes. We're on pep rally schedule today, so remember there's no encore. You go straight to second period. Okay? Let me know if you need me or have questions.